Okay, so welcome to one of my nuggets. I'm actually currently recording a nugget for CBT Nuggets. Right now we have no viewers just yet. I'm sure we'll have some here in a bit. And for the nugget, let me show you my screen real quick. Yes, here it is. I am live on YouTube. For those of you just tuning in, you're in the middle of a CBT nugget. I am recording a nugget live, and I'm doing a nugget on QoS. So I thought, you know what? I am QoSing my home network, and I'm QoSing it to prioritize my YouTube live traffic. So why not configure my QoS while I'm doing YouTube live stream? Thought it'd be pretty cool. So anyways, I'm warning you, as I'm doing this, I'm going to introduce network congestion into my network, and the YouTube live stream might go down. Hopefully not if QoS is doing its job, fingers crossed. And hopefully this computer doesn't die. So let me get some things set up here. And I'm recording this nugget at the same time, so it's pretty cool. Anyways, I'm going to share my screen here in a moment. And we will configure QoS in my home network. Okay, you should be seeing my screen. Okay, here we go. So here's my home network setup. Let me grab my paintbrush here. So I have a lot going on in my home network. This is basically it right here. This is my home router, and I do have a Dmvpn connection going across the interwebs, going to my data center in Dallas, actually. It's pretty cool. And I have a whole voice infrastructure set up, and this is actually for my CCNP collaboration course. So what I want to do is prioritize my voice traffic, which is going to be coming from this phone here, my video collaboration traffic, and my YouTube live traffic, while leaving everything else to just suffer because I want my stuff to be prioritized. Now, right now, my family is in there watching Netflix. They're doing all kinds of stuff. So I'm going to be making sure that I have ultimate priority. Now, I'm using the Hangouts on air. I don't see a way to see chats. Maybe I got to go to a control room or something. Let me see. But anyways, hi guys. Let me switch back to my screen. Okay, so now let me show you real quick all the traffic I'll be prioritizing. No, that's not right. All right. So again, my voice traffic, I'll be having a video call, I'll be prioritizing YouTube and everything else. So without further ado, let's jump into my router and make this configuration happen. We launch my good old PuTTY, load my pretty version of PuTTY, and I just re-IP my network. I forget, yeah, it's right here. Logging into my router. Oh, I forgot, I don't have TACACS on this router. Let me try it again. Shame on me. There we go. Okay. Let me clean this up. And I don't normally use PuTTY. I just use it on my recording computer. I normally use Secure CRT. And let me see if I can view the control room so we can talk while I'm doing this too. Just 1 second, guys. First time using this, so it's a little interesting. I'm using this. Okay, cool. So I should be able to see some chat now. Anyways, okay, I'll be looking at your chats every once in a while, but I'll be mostly configuring things. So here we go. And my router is called Portkey. That is a Harry Potter reference. Don't judge me for that. All right, so let's get into configuration terminal. Now, first thing I want to do for this configuration is configure my class map. My class map is how I control or how I mark my traffic. So let me get in there. My first class, and this is how I identify what traffic. So I'm kind of grouping my traffic, saying, okay, voice traffic, I want to identify my voice traffic, put it into a group so I can then add policy to it. So let me do class map. Some contextual things here. You have a bunch of, or not a bunch of, some Boolean logic here. You can match all of the statements here. You can match any. I want to match any. I will name this. The first one I'm making is, I'm just going to call it YouTube. Now, I'm trying to match traffic that is for my YouTube live stream. Now, when you have, when you're doing QoS, QoS will operate off some markings. Let me pull up my other slide here. Actually, this is fine. So for voice, I want to match this up to DSCP EF, which is differentiated services control protocol, right? I think, yeah. And then EF is expedited forwarding. Essentially, this is labeling the voice as super special and precious. And for those of you who don't know what QoS is, or you're not very familiar with QoS, essentially, I've got my internet pipe here. Let's say this is my internet. And my speed right now, just so you know, my download is between 100 and 200 megabits per second. So that's actually pretty awesome. But the upload is only 10 megabits per second, which I know isn't so bad, but when I'm doing a bunch of stuff, especially when I'm doing live streams and video calls and such, that's pretty important. So now I'm focusing on the upload because my download I never have a problem with. So on the upload side of things, right now with no QoS, traffic is just going and going and going. It's just a wild west. There's no control over it. So voice traffic and video traffic and live stream traffic, it's very sensitive. So when there's a bunch of network congestion, when a bunch of things are happening, Netflix or file transfers, my voice traffic gets stressed out, starts to get a little jittery, starts to experience latency, which is how fast a packet can traverse across a network. And so that starts to spike, and then we got packet loss, which is never good. And so instead of sounding like this, you'll start like this, which is you would never want to listen to that. So what we have to do is during times of congestion, we want to make sure that voice traffic and all this other traffic has priority. We're basically creating a little secure queue, kind of like, when you go to Six Flags. Let me just switch to my face here so you can see my face. Kind of when you go to Six Flags or any amusement park and you wait in lines. I just went to Six Flags recently and I was waiting in a line. It seemed like just an eternity trying to get onto a ride. And then you see this guy just kind of go on another line and he goes right up to the front. You're like, what is that guy doing? Why is he so special? Why does he have priority? Well, he's got one of those fast passes. He's been labeled with a fast pass and he can go right to the front, while all of us general people who don't want to pay for the fast pass have to wait in the line. We're marked as general or best effort traffic whenever we can just get to the front of the line. But hey, priority device comes around, voice traffic comes around, and all of a sudden he's got priority. So that essentially, and this actually is called, you can't see that. Let me change that. I'm so used to just jumping into it. Oh, by the way, does everything sound good, guys? I didn't ask anybody, so how does it sound? let me know and I'll look here in a second. So essentially, this is called LLQ, or low latency queuing, which is this is specially designed for voice, video, any kind of real time traffic. Because when you're talking about voice, it's comes over something called RTP, which is real time transport protocol, operates over UDP, and it's very, very finicky. It does not like being messed with. It's got to have a very clear street. It can't jump over rocks or anything. It's got to be treated very specially. So low latency queuing is a QoS mechanism that allows us to give the voice traffic red carpet treatment. So that is what we are doing. So right now I am identifying the traffic I want to treat like a queen, like a king. I want to make sure they are awesome. So the first thing I'm doing is I'm identifying my YouTube traffic. I'm applying a class map, which is basically saying this is the stuff I want to mess with and get it going. Now, how am I identifying my YouTube live traffic? Sometimes your switches or even the client sending traffic will apply a kind of a label, kind of automatically apply a fast pass to traffic that's really important. So like a Cisco phone will automatically apply the DSP-EF, which is one of the highest traffic ratings you can get. And as long as you're switching your router trusts that rating, it will prioritize that traffic when you have QoS configured. However, I don't have a managed switch. I have an unmanaged switch. I know, shame on me. So I had to figure out a different way to classify my YouTube traffic. So I did find out through Wireshark that YouTube traffic is using a certain port. We do show run section access. And it was, pay no attention to all my access list. It was this guy right here using port 19305. So that's what I'll match off of. So I can match any traffic destined to this port, which should be my YouTube Live right now. So I'll do match, or my options. I'll do access group name, and then I didn't grab that name, YouTube Live. I always like to copy and paste, just makes it cleaner. Okay, cool. So I've classified that traffic. Just taking a sip of coffee because you can't see me. Now I'm going to keep moving on and classifying more traffic. Just going to check the chat real quick. Robot voice, packet loss detected. Not yet. Anyways, now I'm going to classify my my voice traffic. I'm going to name this. I'll do class map match any RTP voice, real-time transport protocol voice. And I'm going to match off of, now you could tell the router, you can actually match off of a protocol. Match protocol, and it'll give you a list of built-in protocols. Cisco can actually look into the packets going across and figure out what it is. I'm not going to be that fancy because I could just type in RTP, which is right here for real-time transfer protocol. I'm just going to match off the DSCP option I know it's going to have. So I'll do match IP DSCP. Options are numerous, and I'm going to match off EF, expedited forwarding. Now, just in case you're wondering, any packet that's not QoS or not marked special, doesn't have the Six Flags FastPass, will be matched with a DSCP 0 because they are nothing. They are what's considered best effort, which is how most traffic will be sent. So my family and they're watching Netflix, they're going to be considered best effort traffic. So when push comes to shove, when congestion is happening, they are the bottom of the barrel. My stuff will be sent first if everything works out. And that's the other thing I want to hit home too, is when we're talking about QoS, it doesn't fix a bandwidth problem. Now, I'm going to say it again. QoS will not fix your bandwidth. Let me get to my face here so you can see my face so I can tell you this. So many people think, oh, we're having network problems. Can we do QoS? Or maybe your boss is like, hey, we're having network issues. Can we do QoS? QoS will not fix a bandwidth issue. If you don't have enough bandwidth to support the devices in your environment, nothing will fix that except more bandwidth or less people. You have to pick one, whichever is easier. What QoS is for is when you have congestion. Now, it's assuming that during normal operation, your stuff works fine because you have adequate bandwidth. But there are times when there is a bunch of congestion, when someone's doing a large file transfer, or when there's a bunch of people in the office for whatever reason and everything's happening all at once. Well, you have to be able to prioritize certain things that are really, really important while other things are kind of pushed to the side. So that's what QoS is for. All these QoS mechanisms I'll be putting into place will only actually happen and be effective when there's congestion. So we'll get into that. Let me switch back. And I'm going to take a sip of water. Okay, back to my router. So it'll be EF. Now each of these can have their, when you're applying DSCP markings, this is a layer 3 marking, basically saying this packet's important or it's not important. Because I could apply a DSCP marking of 0 to this, and my voice traffic would be 0, nothing. They wouldn't care about it. But expedited forwarding is pretty high up in the list. It's right below the most important traffic, which is router and switch specific traffic, control traffic. But anyways, I digress. I've applied that to him now. Voice traffic's important, and we'll get to how we apply that policy here in a moment. I'm going to do a few more things. I'm going to do class map RTP, if I spell it right, RTP video. I forgot my match any. That's my Boolean logic again. And I'm going to match off of DSCP, IP in there, match IP, DSCP, EF. I'm going to match 46, I believe. Yeah, that's what I have here, 46. That should match my video, my video calls. And I'll actually do a video call here in a moment between my DX650 and a Jabber. And it's actually separated between a cube. So it is going across my network. Now, if that's just totally foreign to you, if you don't know anything about that, that's collaboration stuff, which is amazing. And this is actually part of my CCNP collaboration course. So if you're liking what you're seeing so far, I encourage you to go to CBT Nuggets and look at my course, which will be coming out very, very soon, within the next week, I believe. And let's see here. So I've matched up my video. Now I do have my Dmvpn traffic. So when things are really going, like when I was traveling, I don't know if you guys knew I was traveling. I was in Budapest and I was in Paris and such, and I took my lab with me. Now on some of my Airbnbs, the upload was horrible. I mean, I didn't have any bandwidth at all. So whenever anyone would do anything, my Dmvpn time would go down. So I immediately went to work, put in some QoS, and I made sure my Dmvpn traffic, the things that kept my VPN up and running, were prioritized. So when things were congested, my tunnel stayed up. I was still good to go. Just Netflix was buffering a bit. But anyways, let's match on some Dmvpn traffic. So class map match any RTP, or I don't know why I said RTP, Dmvpn. I'm going to match off of a access list I have that matches a bunch of stuff for Dmvpn, and including my EIGRP traffic too. So I'll do match access group name, and I named that Dmvpn QoS. Awesome. Now that's all the groups I'm going to configure. So you may be wondering, well, what about the rest of the traffic? What about everything else? Well, there's another class map called class default. And that's the catch-all for anything you don't specify. And we can actually configure what is going to happen with that. I'll show you here in a moment. All right, so I've defined, so let me just actually draw some more stuff here. So I've classified my traffic, which with my class map. So I've labeled what's important and how to figure out what traffic that is. Now I'm going to do some policy. I'm going to say what to do with that traffic. How much bandwidth am I going to allocate to each type of traffic? And it's pretty cool. I'll show you, there's a few different ways we can do that. So I'm going to get back into global configuration mode, take a sip of water. And the command will be policy map I'm going to name this just YouTube, because my primary goal with this is just prioritize my YouTube live stream, which again, this will go down if it doesn't work well here in a moment. Okay, so here is where I can add some stuff, some configuration to my my class maps and how I'm prioritizing everything. I'm just going to take a look over at the chat, see if anything's down. Collab is fun, man thing, and water isn't coffee. You're right. Let me take a sip of coffee right now. All right, cool. Now, there are some prerequisites to getting to this point in your QoS configuration that is in this previous nugget, which you're not seeing live right now, unfortunately. So if you do want to see that, go watch my course. that's the last time I'll tell you about it. All right, so I'm in the policy map. Now I'm gonna jump into my classes and define what's going to happen. I'm gonna define policy. So first I'll look at the YouTube one. So I'll do class YouTube. I'm in the policy map. I'm in the policy map now. I'm jumping into the class configuration in that policy map. So what I can do now is I'm going to enter what's called priority. Now there's two big ones I'm talking about right now, two big commands. It's going to be priority and bandwidth. Bandwidth. So the difference here is that priority is low latency queuing. And low latency queuing is a combination of a priority queue, which is kind of legacy, and something called I always forget this, CBWFQ, class-based weighted fair queuing. Now that's a mouthful. I know it's kind of confusing, but essentially it's what we're doing here. We're defining classes, we're defining traffic, and then we're going to define how they'll be queued in our internet pipe. And with low latency queuing, it's kind of the new kid on the block. We're able to define a prioritized list of traffic. So that's what we're going to do first, is prioritize the important traffic, which would be our voice traffic, our video traffic, my YouTube live traffic, the stuff that's very, very sensitive and will cry if you put any more traffic on it. So priority, I can specify bandwidth. So I can put in however much bandwidth I want to dedicate to this traffic, or I could do a percent of the bandwidth available. And you may be wondering, well, where does it get that from? It gets it from the interface command. So if I do, I'm not going to show you my interface run command because I do have my IP address on there. If I on the interface, you'll have a bandwidth command. I'll say like bandwidth, and in my case, it'll be 10,000 kilobits, which is 10 megabits, right? So I could do like 10%, and it would devote 10% of my bandwidth to this particular class of traffic. Now, I'm not going to do that. I like to be picky, so I'm going to define how much bandwidth this traffic will get. So I'll say priority. I'm going to give it 6 megabits. Now, pay attention to the usage here. It's kilobits per second. So I'll give it 6,000 kilobits, which is 6 megabits per second. Now, there is a key difference here. So this won't take effect until there are times of congestion. So when my upload pipe, which is 10 megabits per second, when this thing is totally congested, totally crazy, that's when this thing will jump into effect. Now, what priority 6,000 means is that my YouTube live traffic, because that's what I'm specifying here, is guaranteed 6 megabits per second of traffic, but no more. It has priority. It will be put first into the queue, and it has a guaranteed amount of 6 megabits per second, but no more. That's it. That's its limit, because Cisco doesn't want this type of traffic to hog everything else. It gives you the ability to kind of put a cap on it. So that's the maximum it can be used. Now I'm going to go through real quick and configure the rest of it. So I'll do class RTP voice. That was my other class of traffic. For my voice traffic, I'm going to give it a priority command of, what did I give that guy? I wanted him to have 200 kilobits per second. Make sure I'm using the right, yes. I always do the contextual help and see what my reference is, because you can really mess it up. And I'll show you here in a second where if you just assumed it was kilobits per second, you might kind of be screwed. So priority 200. Now the reason I'm doing that is I'm doing G711, which is a codec for a call. It defines how much bandwidth and a bunch of parameters when you place a call. And I only really need 2 phone calls at once in my environment, and a G711 call roughly takes about 100 kilobits per second when you factor in all the overhead and VPN and everything. Normally, without anything at all, without any kind of headers or any kind of overhead, it's 64 kilobits per second. But with everything else, it's 100, so I'm doing 200. We should be okay there. So I'm guaranteeing that my voice traffic has at most, or at least 200 kilobits per second, but no more in times of congestion. Now, we're going to jump into the video real quick. Class RTP video. The same thing, priority. Now I'm going to introduce a new command here in a second, so we'll just hang tight. I'll do priority. I was going to give my video, let's see, 2 megabits per second, so I'm giving it 2,000 kilobits per second. And then my Dmvpn traffic. Class RTP Dmvpn. Oh, I don't know why I keep doing that. It's just Dmvpn. Calm down, Chuck. And then priority. I'm only giving him 500 kilobits per second. I don't think I even need that much. I'm just kind of carving up my 10 megabits per second. Okay, cool. So let me show you what I have so far. Let me do show. Now this is a very handy contextual way to find things when you're in a command line. Because I hate to go back to the global configuration mode or just the start of your configuration. So you can do a do command. You can run any of your show commands right from the command line. Super helpful. So do show run. I can do a pipe and do section and type in policy, and it'll just show me my policy map configuration. Bam, right there. So stinking slick. I love it. Water break. Also coffee break. Okay, and I'm back. So there's all the classes and priorities I've set. Now for the last bit of traffic, and that's everything else, the class default. So I'll type in class default. It feels redundant, I know, but that's just what it is. Now here is where I'm going to do something a bit different. Now I do want to point out one thing. I forgot to mention this. So I mentioned that there was the priority command and the bandwidth. So the priority, when I give it like 6,000 megabits per second, that's the maximum it can use, but it has priority, so it's really special. The bandwidth command, if I were to do the same thing, give it 6,000 megabits per second, that's telling the traffic that it can use 6,000, it's guaranteed 6,000 megabits per second, and if there's more available, it can use more, which is a little confusing, I know. The reason, so so this is only using what is it again? Class-based weighted fair queuing, CBWFQ, which is everything we've done here without priority. So essentially, the traffic gets 6,000 megabits per second. If there is more available, kind of like when you eat dinner at home and you finish your plate and you can go back for seconds, that's the bandwidth command. The priority command is kind of like when you go to eat lunch at school and you get one set meal. You're guaranteed that meal, but no more. So the bandwidth. So again, these don't come into effect unless there is congestion. So that's a thing. However, the bandwidth command, you can use more if there is more available, but the priority command, you don't get to use any more if there is more available, if that makes any sense. But you do get priority. You get first chance to eat, first in line. Anyways, so now I'm going to introduce something else. We've seen the priority command. We've seen the bandwidth command. So we're in the class configuration. Let me do a contextual question mark and see what else is there. We have a lot of options. QoS is a complicated beast. You can do a lot with it. I'm not going to go into everything because that would take forever. I'm not one of those 8-hour live streamers. However, I will cover the police portion. There's actually two big ones you'll see commonly: police and shape. Police, very forceful. He's very restrictive. Essentially, you say, okay, this type of traffic can use, let's say, I don't know, 5,000 kilobits per second. If you go over that, you know what I want to do to you? I'm going to drop it. That's it. I'm going to drop it. That's not fun. That's not fair. But that's what it does, or what you can configure it to do. With shaping, if you did the same thing, 5,000 kilobits per second, it will buffer it. it'll be nicer about it. It'll kind of put it into a queue. And so low latency queuing will also do the same thing in CBWFQ. They will queue it, and shaping is another way to do that. But the thing to hit home here is policing. You have the option to just drop that traffic, which is what I'm going to do right now. So I'm in the class map for class default. This is everything else, all the Netflix, all the Facebook, all the crap I don't want to see. The thing I want to make sure my stuff is prioritized. So I'll do police. You can do a lot here. I'm just going to police how much bandwidth I want it to be able to use. So this is in case there's just something crazy. So I've kind of chopped up my 10 megabits per second. The rest of it, if you're keeping track and you got the math going, is 1.3 megabits per second. Now here, notice this real quick, and this will kick you in the butt if you don't pay attention. The police option, notice the type changed from kilobits to bits. Could you imagine if you were trying to police traffic that was actually kind of important, but you only did like 100? Well, 100 bits per second versus 100 kilobits per second is quite the jump, isn't it? So be careful. That's why I say always do a contextual question mark to see and make sure you're doing the right thing, because that'll get you. Anyways, I'm going to enter 1, 3, and then 5 zeros. I had to keep track of that. 1, 2, 3, 4, 5. That's 1.3 megabits per second, I believe. Yes. Okay. Now you have some options here. You can either press enter. It'll take you into another menu where you can do the same thing. I'm just going to do it all on the same line. You can do a conform action, which is when it's obeying this rule. So you can adjust what happens then. The default conform action, when it's under 1.3 megabits per second, is to transmit the traffic. That's good. That's what you want. Now, here are the other options. You can do exceed. You can have like a reversible rate. You can do a violate when it violates both of these combined. I want, when it exceeds the traffic, I want it to drop. So when everything else in my network, when it's congested, when it exceeds 1.3 megabits per second, I want it to drop that traffic so everything else is safe, secure, nice, and safe. Did I say safe enough? Safe, safe, safe. Anyways, here we go. Now let's take a look at our policy map. Policy. All right, so that's what we got here. We got a bunch of priorities. So this is everything in our priority queue. We didn't do anything with bandwidth. We didn't do anything with CBWFQ. This is all low latency queuing. And then we have policing on our last bit of traffic, which I don't care about because this is all my stuff, all the stuff I care about. Coffee break. So the last part, so we define our traffic. We define the rules and how we want to treat our traffic. Now we're going to apply all this stuff to an interface. It'll be my outbound interface, my interface with that's going out to my ISP. Open to it, interface FA4. And here's the command. It'll be service policy. You specify your direction. I want to be looking at the outbound direction. Output. Then you put in your policy name, which mine was YouTube. Now, I want to be careful here because, again, this is a live stream and this is affecting my traffic at this very moment. So hopefully I don't go down. So it was nice knowing you guys. Here we go. Am I still here? Am I still here? Okay, I think I'm still here. Now, we need to verify, right? We want to see if this is actually working. We want to see if our traffic is being watched and monitored. So let me clean some things up here. Clear scroll back, reset terminal. Back in the global configuration or just the standard mode. And I'll do a show show policy map interface FA4. This will show me everything being matched. So right now, let's take a gander. Let's see if my stuff is matching appropriately. First, it shows us my class map for YouTube. I'm being matched on YouTube right now. That's good. So we know that the port I specified is actually matching my YouTube live traffic. This is what's happening. Drop rate, nothing, exactly what I want. It tells me my priority queue settings and everything. Beautiful. Right now, there's no voice. I don't have any voice calls going across. No video. Dmvpn. I do have some Dmvpn because my tunnel is currently up. That's good. That's what I want to see. And then class default is going to have a bunch of stuff because that's everything else. Now, right now, there's not congestion, so nothing is being dropped. So you would normally see, you see the conformed. This is everything that's meeting the criteria. That's not going past the 1.3 megabits per second I specified. If it was, it would be exceeding and it'd be dropping that stuff because I don't want to hear. Anyways, I am now going to introduce some congestion. So here we go. First, I'm going to start a voice call. So let me, I want to turn my video back on so you can see me. Okay, so I'm going to place a phone call. This is going over my Dmvpn connection to my voice gateway, to my ITSP, my Internet Telephony Service Provider. This is all stuff you'll learn and love in collaboration, and it's going to come to my cell phone. Here we go. All right. Call is live. I'm going to mute that so we're not hearing echoes. Now let's see if that traffic is showing up. Let me get you back on there. Do the same command. Let's see if RTP voice. Yeah, there it is. RTP voice. Scroll up where it's nice and clean. It is now matching on traffic. Excellent. No drops, no congestion. So far, we're looking pretty stinking good. Actually, no, look at this. My default is already exceeding and dropping. Interesting. It's already had enough. Huh. But the live stream is still strong, I think. We're still looking good. Okay, you scared me there, Bert. All right, so now I'm going to introduce the video call. You'll actually see this pop up because I'm using Cisco Jabber. And this is Tom Riddle. So I'm going to get my DX650 and place the call. This will be a call using SIP URI. I'm using a lot of words that you don't know, but I'm trying to get you excited about collaboration. Let me place the call. I'm actually dialing an email address, not a phone number, which is really cool. Okay. Now you see the back of me. I'm going to do a Control-Shift-S to look at my statistics. Echoey. But you can see that there's some packets going across. It's a lot of traffic. So now I'm live streaming. I'm doing a video call. I've got a voice call. I think my voice call actually dropped. Huh. Didn't like that, did it? But my video call is still up. And is everyone here? Oh, Dallas. Yes, I'm using your DX650. Dallas Splon in the house. Guys, Dallas Splon is amazing. He actually hooked me up with a lot of Cisco voice stuff. So thank you. Now I've got some echo going on. I'm going to see if I can mute this sucker. I haven't used Jabber in so long. Oh, there we go. Okay. So now I got a video call going. Let me do another show. And yeah, I'm exceeding and dropping. Let's go up here and look at our video. Oh, we're not matching video. Huh. What am I missing? Did I match off the wrong DSCP value? Oh, I think I did, actually. I wasn't even paying attention. Look at this live troubleshooting. We do show run section class. And let me see here, RTP video. Oh, I'm matching off of EF on video. I must have just. Why didn't y'all tell me I did that? Let me just fix that. So I'll take out the DSP EF. I'm going to match IP DSCP. I think I put in 46. I wasn't paying attention. So CS4. Oh, matcha. Match IP DSCP CS4. Hey, if I spell that wrong one more time, that's why my voice call dropped, by the way. It totally just killed everything in that priority queue. Interesting. CS4. Haha, I got it. And then AF41. So now let me do a quick show policy map and see if it's matching. Ah, now we got some matching in video. Beautiful. I'm gonna get that voice call back up because I really want to have everything going at once. Okay, voice call is up, video call is up. Just so you can believe me. Hey. Anyways, Do it again here, see what's going on. Okay, we're dropping, but everything is still up. Everything's still up. I love this. Okay, now well, I think I have everything that's I wanted to be priority. So I got voice, YouTube, and RTP video. Now I'm going to introduce some congestion. I'm going to start a file upload on Google Drive. And this should just obliterate my traffic, right? It's a 2 GB file up to Google Drive. It is uploading. And we are seeing some drops. Yep. And the live stream's still up, I think. How do I sound? Like, real quick, guys, tell me how things are looking. Well, my voice call just dropped. I think it's because I was out of minutes on my ITSP. But how's everything else? The video call's still up. And I think things are good. Guys, can y'all still hear me? It's making me nervous. Oh, cool. All good. Okay. I forget the chat's delayed, so it scared the junk out of me. Anyways, okay. Yeah, so it's dropping packets like crazy. Everything's congested, but my stuff is good. It's awesome. Anyways, let me switch back to my video. If I can find it here with all my screens open. Oh, my video's not starting. Why? Oh, because my jabber's using the camera. Duh. Let me stop it. Blah, 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 blah. Okay. Now let me have it. Okay, I'm back. Jabber was stealing my stuff. So I think everything is down. Let me stop that humongous file upload. All right. So guys, that was just a kind of a primer on QoS. This is I was doing this for my CCNP collaboration video because I wanted to show implementing QoS in my home network, and specifically for my voice traffic and also my video traffic, my live stream traffic to YouTube. So I thought it'd be cool to do it live, and yeah, it was successful, I think. Let me jump into the chat, see if there's anything I can respond to with you guys. Yeah, I think it's I'm getting pretty tired here because I've been working on QoS all day and I'm exhausted. But it's fun. It's really awesome how you can implement all these controls and prioritize traffic in your network. I think that's pretty much all I have. If you have any more questions about QoS or you need any help on your configurations, drop a comment in the YouTube comments, and I will try to help you, if not someone else, because I know there's a lot of experts out there who are way smarter than me. But this is stuff you can pick up pretty quick. There's a lot of walkthrough guides, and if you have a Cisco router, I mean, a lot of you have a Cisco router in your lab, you can implement this in your home network and play around with just prioritizing certain traffic. Maybe get your wife off Facebook so much and just lower her Facebook with policing and give her like 128 kilobits per second, get her back to dial-up days. So there's a lot of things you can do. Justin Wiley asked, how's T-Shoot going? T-Shoot is going horribly because I haven't had a lot of time to study for it. I've been doing a lot of course creation. I'm almost done with this course. So my plan is the last 5 days. So I've got 5 days starting tomorrow. I'm going to make it my full-time job to study for the next 5 days. So it's like going to be boot camping, waking up early, labbing like crazy, and I'll try to document some of that process on YouTube and Instagram and Twitter and stuff. But I'm in trouble. My video's lagging. Oh no. Anyways, so I am taking my CCNP on the 15th. But anyways, I've got a lot of video editing to do here soon. So thanks guys for tuning in. Thank you for joining me in my QoS configuration. If you know of a way I can do my QoS better, let me know. And if you have any questions, again, let me know in the comments below. That's about it. I will catch you guys later. And I'm going to talk while I end my live stream because there's a lot of buttons involved. And goodbye.